For much of the rest of the semester, we will be studying lines in 2 dimensions, such as this one here. Let us call it L. So this line L is the type of thing we'll be studying throughout much of the rest of the semester. You could have a line that looks like this. It could go down from left to right. It could be completely horizontal. It could be vertical. We are going to study a whole host of lines in 2 dimensions. Notice here that this particular line L crosses both the y-axis and the x-axis. The specific point where the line L crosses the y-axis is what we call the y-intercept point. And the specific point where the line L crosses the x-axis is what we call the x-intercept point. These points are so important that we give them names because they play a big role in the theory of lines, and they also are often very important in applications, which we'll see in the near future. Let's actually write in the coordinates of each of these specific points. Notice that the y-intercept point is at 0, 3, and the x-intercept point is at approximately -7.5, 0. It's crossing the x-axis at an x-coordinate between -7 and -8, so I just approximated it at -7.5. What do all points on the y-axis have in common? For example, this coordinate right here is 0, -2, and this one right here is 0, -5. What do all three of these coordinates, of these points on the y-axis, what do they have in common with respect to their coordinates? Well, they all have an x-coordinate of 0. That means any y-intercept point always has an x-coordinate of 0. This will play an important role in how we'll find y-intercepts in the coming example. What about points on the x-axis? For example, this point right here is -3, 0. This point right here is 1, 0. This point right here is 5, 0. What do all points on the x-axis have in common? Well, notice all 4 of these points on the x-axis here have a y-coordinate of 0. What that tells us is in order to find x-intercept points, you know the y-coordinate must be 0. Let's see an example. Find the x-intercept and the y-intercept of the line represented by the equation 2x plus 3y equals 12, then graph the line based on your results. Let's first try to find the x-intercept. Well, as we saw on the previous page, any point on the x-axis has a y-coordinate of 0. We have that summarized over here. So this specifically means if we've got the equation 2x plus 3y equals 12 and we want to find the x-intercept, plug in a value of 0 for y. So we've got 2x plus 3, we're going to put in 0 for y equals 12. Now we have this one equation just in x for which we can solve for x. 2x plus 3 times 0 is 2x, of course, equals 12 still. And if you divided both sides by 2, you get x equals 6. So the x-intercept is the ordered pair 6, and we got that x-coordinate of 6 when the y value was 0. So 6, 0. And if you want to find the y-intercept, just like we saw on the previous page, any point on the y-axis has an x value of 0. So if you've got an equation of a line and you want to find its y-intercept, you simply plug in 0 for x. So we'll do that. We've got 2 times in place of x, we'll put in 0, plus 3y equals 12. And then we can solve this equation for y. 2 times 0 plus 3y, simply 3y. 3y equals 12 can be solved by dividing both sides by 3, and you get y equals 4. So our y-intercept is 0, 4. We can now graph the line based off these 2 points. Anytime you have 2 points of a line, you can always graph the line. So 0, 4 is this point right here. 6, 0 is right here. And then, of course, we connect them. We've got a graph of our line. Let's look at another example. Find the x and y-intercept of the line represented by the equation f of x equals -5x plus 20. So in this case, the input-output relation is written in function notation. However, we still need to be able to find the x and y-intercepts. Let's start first with the y-intercept. So as we saw on the previous screen, The y-intercept always has an x-coordinate of 0. So we're going to plug in 0 for x, and we'll do that in the function notation. So we have f of 0 is equal -5 times 0 for x plus 20. And if we do this arithmetic right here, -5 times 0 plus 20 is exactly 20. So the y-intercept, again, this is our input here. The y-intercept is 0, comma, this is our output. So it's 0, comma, 20. Let's now find the x-intercept. And on the previous screen, to find the x-intercept, you need to plug in 0 for y. But in this case, we're not using the y variable. Instead, we're using the function notation. So what is equivalent to plugging in 0 for y? Well, that would be putting 0 in place of f of x. So we can add to this one here. If you want to find the x-intercept of a line when your equation is written in function notation, we want to let f of x equal 0. So we're going to plug in 0 in place of f of x, and that's equal to -5x plus 20. So to find the x-intercept, you end up setting up an equation that you need to solve for x. So we'll subtract 20 from both sides, giving us -20 equals -5x. And we'll divide both sides by -5, giving us 4 equals x. And of course, the x-intercept is an ordered pair. We just found the input value of 4, and the output value is the 0 that we plugged in for f of x. So our y-intercept is 0, 20, and our x-intercept is 4, 0. And we should be able to find the x and y-intercepts whether the equation is written in function notation or not. We're going to look at one last example, and this last example is an application. And you're going to see that in applications, the x and y intercepts are often very meaningful. In this example, Sue has a gift card to Dick's Sporting Goods, her favorite store for purchasing running shorts. The amount of dollars Y remaining on her gift card depends on the number of pairs of shorts X that she's purchased, which is represented by the equation Y equals 100 minus 14X. First, we want to find what's the x-intercept, but then we also want to say what is the practical meaning in the context of the application. In the previous problem, you were not asked for a practical meaning because they were not application problems. When you have an application problem, you can then say what these ordered pairs actually mean for, in this case, for Sue. What does it tell Sue? So we want to find the x-intercept and give its practical meaning, and we want to find the y-intercept and give its practical meaning. So we've got y equals 100 minus 14x. This case, it's not in function notation. To find the x-intercept, we're going to plug in 0 for y. We get 0 equals 100 minus 14x. And now we need to solve this equation for x. Typically, you would subtract 100 from both sides, most students. However, I just want to show you, you could approach a problem like this differently. Instead of subtracting 100 and then having negative 14x left on the right, you could add 14x to both sides so that you don't have a negative coefficient anymore. So this is just an alternate way of doing it. You do not have to do it this way. And then from here, divide both sides by 14. And when we've been writing our solutions in the past, we've been essentially writing the fractional solutions, but because this is an application, it probably would be valuable to have a decimal approximation. So this is approximately 7.14. So again, that is not the x-intercept. The x-intercept is the ordered pair 7.14, 0. Now, we can also say what the practical meaning is with respect to Sue. What does this tell Sue? Well, this again is a number of shorts, and this right here, the output Y, is the amount of money left. So she can buy 7 pairs of shorts. You can't buy 0.14 shorts. She can buy 7 pairs of shorts, and then she'll have no money left on her card. If Sue buys 7 pairs of shorts, she'll essentially have no money left on the card. And the reason that I wrote essentially in here is because technically, if we were to plug 7 in here, it would be a little bit more than 0, since it's really 7.14 that would make this y value of 0. So that's why I wrote in the word essentially. So we have the x-intercept here and the corresponding meaning here. Let's find out what the y-intercept is and also say what its practical meaning is. So if we want to find the y-intercept, we would plug in a value of 0 for x. So we've got y equals 100 minus 14 times 0 for x. If you do this arithmetic, 100 minus 14 times 0 is simply 100. So our y-intercept has an x value of 0 and a corresponding y value of 100. So this is the y-intercept, 0, 100. But now we can say what the practical meaning is for this. So if Sue has not bought any pairs of shorts, that's what the 0 represents, then she would have $100 left on her gift card. So essentially that $100 is the initial value of the gift card. But let me write it the way I initially said it. If she hasn't bought any shorts, she has $100 on the gift card. Said differently, her initial value, the initial value of the gift card is $100.